In this video, we're going to be finding values of piecewise defined functions. A piecewise defined function is a function defined by using different equations for different parts of their domain. The domain of a piecewise function is the union of the individual domains. In problem 2, it says use the function j of x is equal to x squared plus 3 if negative 2 is less than or equal to x is less than or equal to 0, negative x plus 3 if 0 is less than x is less than 3, and the absolute value of x minus 3 if x is greater than or equal to 3. So on the right, all of these if statements, those are the individual domains for the different parts of the equation, and the union of all of these domains is the domain of the piecewise function. So it's important when you're evaluating a number that you make a decision on which piece of the function you're using based on the individual domain and evaluate the proper equation. So in A we have j of negative 2, which means x is equal to negative 2, and when x is equal to negative 2, then j of x is equal to, so here we can see the very first equation is if negative 2 is less than or equal to x is less than or equal to 0. So when x is negative 2, j of x is x squared plus 3. And now we'll plug negative 2 into this equation, and we get negative 2 squared plus 3. And negative 2 and negative 2 squared is equal to 4, and 4 plus 3 is 7. In B, we want to look at j of 0. So when x is equal to 0, then j of x is equal to, and we can see that 0 is included in the first domain, so again we're using x squared plus 3. And now we're going to evaluate j of 0, and that's equal to 0 squared plus 3, and 0 squared plus 3 is equal to 3. So j of 0 is equal to 3. In C, we want to evaluate j of 3, so when x is equal to 3, then j of x is equal to, and if we look at our domains, we can see that j of x is equal to the absolute value of x minus 3 if x is greater than or equal to 3. And now we want to evaluate j of 3, which is equal to the absolute value of 3 minus 3. And 3 minus 3 is equal to 0, and the absolute value of 0 is 0. So we have j of 3 is equal to 0. In D, we want to evaluate j of 2, so when x is equal to 2, j of x is equal to, and we go up to our individual domains and we can see that 2 is in between 0 and 3, so j of x is equal to negative x plus 3. And now we're going to evaluate j of 2, which is equal to negative 2 plus 3. So j of 2 is equal to 1. In E, we're going to evaluate j of 15. So when x is equal to 15, then j of x is equal to, and we look up at our individual domains, and 15 is greater than 3, so j of x is equal to the absolute value of x minus 3. So j of 15 is equal to the absolute value of 15 minus 3. And then we have j of 15 is equal to, and 15 minus 3 is 12, and the absolute value of 12 is 12. In F, we want to evaluate j of negative 6, so when x is equal to negative 6, then j of x, and now we're going to look up at our individual domains, and we can see that negative 6 is less than negative 2, which is the smallest value in the domain of j of x. So j of x is undefined and it's undefined because j of x is undefined for values less than -2. And that's all for this video on finding values of piecewise defined functions.